Hey guys, Buildzoid here, and today we're going to be adding some fuses to that reference GTX 980 Ti that I repaired because I decided to shunt mod it. And then I thought about the consequences of that for a bit, and I was like, you know what? Like, on one hand, I want a higher power limit. On the other hand, the power stages are, first, both of them have damaged pads, so thermally they're not doing so hot. Or actually, they're doing hotter than usual. Other than that, the replacement power stages are, are 50 amp parts instead of 60s, because I don't have the 60 amp parts that a 980 Ti normally has. Like, I don't have another card that I could pull good 60 amp parts from. So, yeah, the VRM is, that part of the VRM is basically downgraded. Now, to try compensate for that, I have, replaced the VRM thermal pad and made it a lot wider than it used to be to try sink some more heat out of the PCB itself. I'm not sure how effective that is, considering this is a metal plate. This is not really a, good way to try cool a VR. Really, this isn't a good way to cool anything, but this is just the only, option I have for this card currently. So, yeah, we're kind of stuck with that, an aluminum plate for cooling. So, that's, so basically, this VRM likes to explode at the best of times. After my repairs, it's even worse than usual. And I've decided to shunt mod it, so I really don't want the card to blow up, so, yeah, I'm gonna have to do something about the whole, power delivery situation to make sure, well, the thing is, even if I don't want it to blow up, if you want to avoid a card blowing up, you don't run it at high power consumption, right? But I want to run it at high power consumption, hence the shunt mod. So the next best thing I can do is, if it blows up, I want to minimize the amount of damage that the explosion is able to cause by limiting how much energy is available to the explosion. So we're going to be putting some fuses on the card. Now, unfortunately, those fuses aren't going to be quite as effective as they would have been on a bone stock 980 Ti, because I got a little bit carried away on the cap mods on the back of the card. Especially this right here is a potential concern, because this is extra input filtering, so there's more energy stored on the card than there would normally be, which means even if the fuses blow, that dead power stage is potentially going to be, well, it's not going to be emptying out all of the capacitors, but it is going to be discharging, two of them, I think, because I'm not actually sure how these are, distributed between the various power inputs of the card. There is 6 of them. Yeah, there's 6 of them. So, because you have an 8-pin, a 6-pin, and the PCI-E slot, I guess it could be 1, 2, and 4, as in 4 caps for the, I've not traced it out. I can't be bothered. I'm not going to bother. Anyway, so yeah, we're going to add fuses. Now, I think for this inductor, which I believe is for the PCIe slot, we're just going to get rid of that inductor, replace it with a fuse. Now, these, however, I mean, we could just replace them with fuses. That's one option. Screw it. We're just replacing them outright. I was going to go all complicated and because these inductors are there to basically prevent the VRM switching noise from affecting the rest of the system. On the other hand, I'm running this card on a 1200 watt power supply. I don't really think that is a concern. The power cables themselves have some amount of inductance. There are GPUs and motherboards out there that don't have any filtering inductors whatsoever, and you don't hear people complaining about them. I've significantly upgraded, well, okay, I've not really, these are 180s, I think. Oh no, these are 100 microfarads, so I've not massively increased the overall capacitance of the card, but I have improved the input filtering quite a bit. There's also these extra multi-layer ceramics, so I think it'll be fine. And that's not the right way to deal with this, but I've decided, it is way easier to just desolder the inductors entirely and replace them with fuses than trying to figure out how to jam the fuses onto the card along with the inductors, because I do want to be able to use the thermal delaying system. Again, calling this a cooling... Well, actually, how much space do I have? Well, this one's under the plate. That one's just getting replaced with the fuse. But there's actually kind of a lot of space for maneuvering around these two. So what I might do... So actually, you know what? I'll get creative with it, and we'll try to get the fuses on there and keep the inductors. Yeah, for like the main power deliver... Like the main power connectors. But the PCIe slot, I'm not concerned about that. Like, the thing is, this... I don't really think there's many, like, on most motherboards, like, so straight up, it's not going to affect the CPU power delivery. I'm not sure if it could potentially affect some of the minor power rails, but on a lot of motherboards, they'll use the 5-volt rail for the minor voltages, not 12 volts. So, yeah, so hopefully this shouldn't really have any downsides. Also, this being a, this being for the PCIe slot, though this is a higher inductance inductor, so... Like, arguably, this one's more important than these two. I still think it'll be fine. Like, low-end like, input filtering components are one of the first things to get scrapped on low-end hardware because, like, inductors are expensive. Less inductors, cheaper. So, yeah, anyway, let's get the mic out of the way a bit and get to soldering. So we're gonna start with the PCIe slot. Actually, I should probably show you that it is actually connected to the PCIe slot first. So, let's get the multimeter in frame. Hey, you can actually see everything. So, I'm going to go on to the 12-volt part of the PCIe slot, which should be like these two pins on the beginning, and... Yeah, so that goes straight to the PCIe slot, as you can see. And that's just going against ground, so... Yeah, so that just goes straight to the PCIe slot. This should be for the 6-pin, that should be for the 8-pin. Anyway, let's get to desoldering the inductor and replacing it with a 10-amp fuse. I'm using a 10-amp on that because it's for the PCIe slot, and also I want to preserve my 20-amp fuses. I only have 3 of them now, so that's part of the logic there. We're just going to go with the soldering iron. This is currently set to 340 degrees Celsius. Oh, actually, it's set to 340, yeah. Okay, this shouldn't be too difficult. That is putting up a surprising amount of resistance. Normally, the PCIe slot power plane is kind of weak, so... Go... Yeah, that is... I'm very surprised. Normally, like, I'd expect the inductor to just come right off at this point. Like, I'm trying to lift it up on one side, and... Like, admittedly, the PCB is cold right now, but... I still didn't think it would put up that much resistance. Oh, there we go. Yeah, so that just took a while. So apparently a pretty substantial power plane over there. Let's get the other leg. I don't really care about preserving the health of this inductor. Up. Even though I don't think I have a replacement for this specific shape. But, well, shape and value. But, yeah, anyway, so now we got our 2 pads. Let's grab one of the 10-amp fuses, and we're just going to pop that on there, and that's going to be the end of that. Funnily enough, there are some, I think Pallet does this. There's like a lot of, I don't think they do it on their newer cards, but on a lot of older Pallet cards, you can actually find like inductor mounting spots where instead of inductors, they just have fuses. Yeah, so I'm not the first person to come up with the idea of just replacing inductors with fuses. Like there are actual manufacturers that just straight up do that. Oh, there we go. So I flipped the fuse over so that I can see the value on it. Okay, I think I'm gonna need more solder. Because I'm like trying to bridge the fuse onto there, because the fuse is a bit too small for the pads. go. And that was nice and easy. And it doesn't look so... It's not quite as... There. I want a good connection. Oh, that actually disconnected it completely. Great. This is a bit awkward with me, like, not being able to, like, lean over the PCB. Okay, now it's properly connected. Yeah, cool. I'm happy with that. So now we can move on to the other two. Now, these are going to take a lot more heat, probably. Actually, they're sort of far out on the PCB. Since they're on the outer edge, that might actually not be the case. Yeah. Anyway. Let's get to it. And so the plan for this one is to just lift it up, like, lean it over, and then put the fuse in between it and the pad on one side. I don't think I'm going to try to completely move the inductor. Try and improve the thermal transfer from the soldering iron to the board. Well, okay, yeah, this one's more stubborn. It's also bigger, which isn't helping. Oh, now it's getting loose. Yeah. And there we go. Now, one of the concerns with this is if I lean it too high, like if I lean it up too much, it's going to potentially collide with the heatsink. So I'm going to test fit the plate on and see how much taller that is. Okay, I think I'm going to move it back a bit as well, like slide it down the pad so that like I get a triangle shape with it and the fuse instead of the fuse sticking straight up. Oh, wait. There we go. So I moved it back a bit. And we just lean it up again. And we just put the fuse in place. Should be a lot easier because I'm not trying to like bridge a gap that's bigger than the fuse is. And this time I'm going to use a 20 amp fuse because this is on the 8-pin power connector. It would be kind of dumb if I blew the fuse. Like, the thing is, for the shunt mod, I just used a piece of wire. Now, it is a very thin piece of wire, so I'm hoping... Like, I didn't want to shunt mod the card by, like, 100% or something, because I don't think the VRM would survive that. But I did want a bit of a shunt mod, and so the issue with using a random piece of wire for your shunt mod is that you don't know exactly how much you reduce the resistance unless you have a milliohm meter, which I don't. So, yeah. Oh, nope, that's too low. Pan. It's kind of awkward to get contact, and yeah. I'm in contact with everything right now. Should probably add some flux. Yeah, okay, we're gonna add flux. Because, I'm getting really terrible results right now, so. Go. The thing is, the fuses aren't meant to be soldered, like, these are SMT fuse, like, yeah, these are surface mount fuses, so they're really not meant to be done with a soldering iron. Like, they're not designed for that. It can be done, but it's not what they're designed for. Okay, there we go, got it in there. Up. That looks horrific, but it's on there and the inductor is floating, so. I don't know if you can see it right now. Oh, wait, no. So, I think you can kind of see it. So, yeah, anyway, we need to do that on the other one as well, and that's going to be way more difficult. Because the other one does not have as much room. I wonder how form-fit yeah, actually, we might be okay. Because the capacitors are really tall in that area, so it might not cause any issues. Though getting at that inductor is gonna suck. Yeah, that's just gonna suck. Oh, well. Come on. Well, the flux really speeds the process along, doesn't it? Yeah, I should have just used it. I should have been using it the whole time. That's what you get for being lazy. Where'd my fuse? Oh, right, the fuses are under the GPU. And so the funny thing is I was also planning to use these 20 amp fuses on an RX 580, and now that's not going to be happening because, yeah, that's, like, the RX 580 needs, I think, actually I might be able to do the RX 580. I think it's a single 8-pin power connector, so it might be okay. Well, this is going to be really awkward compared to the... Yeah, this one's going to... Well, I guess maybe I could go off of the shunt resistor, but... Nah, because the... Yeah, wait, how much room do I have? So that's the main concern for me with this, is like making sure that everything still fits under the plate. Yeah, no, I don't have a lot of room. Yeah, okay, I'm not moving that. I was thinking like maybe shuffling the inductor sideways and then going from the shunt resistor to the inductor, but that's not going to work. So we're going to have to go from the pad for the inductor to the inductor, which is what I did on the other one as well, so... Oh well. It's just that here we have less space to do it in, so I was kind of hoping I wouldn't have to do it that way, but oh well. I kind of enjoy when, you know, you like the challenge of like making mods fit on stock cooling systems, because if you get rid of the stock cooling system, you can just, like, I could just use extension wires for everything, and it makes life so much easier and boring. There we go. So I've just added it to the inductor right now, and now we're gonna have to get it onto the pad. Which, my plan for that is to, like, kind of extend the pad and then try to get the fuse onto it. Is it? Think? Nope. Yeah, like making contact with the fuse and the pad at the same time is... Oh, there it is. Yeah, okay, now it made it. I'm also going to do the other side just to make sure that the fuse is actually properly connected. It would really suck if this didn't work properly because the connections are bad. Go. Well, it doesn't look good, but it should be functional. I'll do a bit of cleanup. There we go. Like, it's still not going anywhere, so... And it looks mildly better, which is what I was going for. Let's also get this. It doesn't accidentally, like, short out against the plate, because I think I also ruined the... Yeah, okay, I'm happy with that. It's gonna... I don't really think I can... Can I show that on camera, maybe? Wait. You can probably kind of make the fuse out. Because I can't see what the camera is seeing properly right now. I don't have a monitor for it. So, yeah, but you should be able to make out the fuses. Anyway, so that's it. That's fuses installed. I mean, you know, if we measure from... No, that's the ground. 12 volts is the inside pins. So if I measure from... Well, actually, no, I'm not going to bother. 980 Ti's are too complicated. Just... Oh, actually, no. What I could do is show you that, like, if you measure, it, like, that the fuse is properly connected, if we measure from the shunt resistor through the inductor, right? So we go shunt resistor, inductor. And can you guys actually see anything? But, like, you can see that it's 0 ohms. Oh, wait. Contact issue. I mean, actually, if I go against the 6 pin, there. Yeah, you can see that. And if I go against the 8 pin, which, fortunately, 8 pin... Am I? No. Okay, I'm not going to get in there like that. Oi. What? 100K? Oh, I must be on the sense pin then. Okay. I mixed up the order of the pins. There we go. Yeah, I mixed up the order of the pins. I was on the sense pin, not on the 12 volts. So anyway, so yeah, the fuses are connected properly. Anyway, that's it for the video. So yeah, if you have a card where you would like to do dumb things to the power limit and you are concerned about blowing a hole in the VRM, the fuses will not stop the VRM from blowing up. That's not what they're for. But they will prevent the explosion from potentially, you know, killing the core, or the memory chips, or the memory controller, or just the rest of the card, right? Because the problem is when a high-side MOSFET fails, it typically fails closed, so it sends 12 volts right out the output. And how much damage that does depends on how quickly the 12 volt is cut at the, like how quickly the 12 volt supply is basically removed. Your power supply has built-in overcurrent protection. At least if your power supply doesn't suck, it should have overcurrent protection. And so when a MOSFET fails like that, it should trip the overcurrent protection. But your power supply's overcurrent protection isn't isn't necessarily going to be super fast. And these kinds of fuses, these little like small SMD fuses, generally can help. Also, the fuses take out the guesswork of like, oh, the card doesn't turn on and I don't know why. So if you like have the VRM blow up, you don't accidentally send 12 volts through it again, right? Because that's another way that you can cause even more damage is like the card, because when the card trips your overcurrent protection, it'll just like your system will just shut down. And then you might think, oh, it just shut down. I'm just going to power cycle the PSU, turn it on again. And when you go do that and you trip well, this time you should be tripping the short circuit protection, but again, you're potentially sending 12 volts to the output of the VRM, which is really, really bad for everything on the output of the VRM. Like if you power cycle a shorted out VRM enough times, eventually it will kill whatever it's connected to. So if you have like a motherboard where the VRM failed, every time you power cycle it, you're running the risk of killing your CPU. Same goes for a GPU. If the VRM fails, every time you power cycle it, you run the risk of killing your memory chips, your memory controller, your core, everything, right? So that's what the fuses are there to prevent, is that the fuses are going to blow up, and when next time you try to power cycle it, it's not going to send 12 volts to the output because the fuse will have disconnected the VRM from 12 volts. Now, the card will also be unable to start, but at least now you're not accidentally causing more damage, and you're going to be forced to basically go, oh, the card actually like failed because the fuses are blown now, which is why it doesn't start. So that's the point of this, is like, this is not going to prevent this sketchy VRM from potentially blowing up again, but hopefully it'll minimize the amount of damage that it will cause if it blows up again. Anyway, that's it for the video, so hopefully this was somewhat interesting, even if it wasn't particularly fast or good in terms of soldering quality. The thing is, I really don't want to put a ton of effort into this card, because, like, on one hand, I don't really want it to die again. On the other hand, I got it for 25 quid off of eBay. And it's basically it's a test subject. It's you know, like, I want to do many experiments, which is why I want to keep it alive as long as possible. I don't really care about doing good, like being nice to it, like being overly, you know, nice with any modifications. So yeah, anyway, that's it for the video. Thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the HOC Teespring store where you can pick up shirts, hoodies, posters, you know, the usual YouTuber merch. There's new hoodie designs on the Teespring store right now. And then I also have a Bandcamp. There's a link to that down in the description below. And that's it for the video, so thank you for watching, and goodbye.